let's see. So do you have stuff you can verbalize, or do you need to send me something?
Hold on a second. I got one thing. It says, let's see. Where are we numbered? All right. I can read this one to you.
Okay.
If it's a word problem, do you think you can get this?
Well, let's try it. Some word problems I can do without reading, but
Okay. It says, if the data are normally distributed with a mean of 0 and a standard deviation of 1, approximately what percentage of the data lies between -1 and 2?
the mean was 0 and the standard deviation was 1, correct?
Yes, sir.
So, if I take the mean plus 1 standard deviation,
Yeah.
65% of the data lies in that zone. And it's evenly distributed.
Why is that a 10 and a -10 though?
That's not. It's -1 sigma, 1 standard deviation, and the other side is +1 standard deviation.
Okay.
You said the standard deviation. Well, yeah, I'm basically just drawing the general here. Since 65%, it's not 65, it's 68. 68% of the data lies within 1 standard deviation of the mean.
Yeah.
And you said a standard deviation was 1, correct?
Yes, sir.
So I'm going to label those points 1 and -1. And what that means is that 34% is in that zone and 34% is in that zone. Now, what I'm drawing here is a general. This applies to anything, and that's why I'm labeling it funny. That's 2 standard deviations.
Huh. And that's a 2 thing?
This is true with any bell-shaped curve. And what is true is that 95% of the data lies within 2 standard deviations of the mean. So between this point and this point, I would have 95% of my data.
Let's see.
I think my numbers are correct. Do you have the numbers? There's 3 key numbers. I know 68% is correct. I think 95% is 2 sigma, and then 3 sigma is 99.4%, I believe.
Okay.
Do you have that?
I don't have that.
Anywhere?
I don't have it.
If you don't have it, I probably should look it up.
I mean, I just don't know how to do this problem, so.
Well, it all starts here, knowing these answers. By here, I mean with this graph that I'm drawing. That's a general graph. Let's take out the 1 and the -1 for a moment. Okay, so here's the situation. If you are within 1 standard deviation of the mean, 68% of the data is going to fall there.
Yeah.
95% of the data is going to fall within 2 standard deviations of the mean, and 99.4% of the data is going to fall within 3 standard deviations of the mean. So if I graph all of that out, it's got to be 95%. In other words, from here, and we're getting to your problem, I haven't forgot it, from there to there is 95%. Well, how does that break down? If that's 68, I got another 27, that's 13 and a half there, and 13 and a half here. Now, your problem said what percentage of the data falls between -2 and 1? Is that correct?
Yep.
Well,
Yes, sir.
Since sigma was 1, then -2 sigma is at -2, and 1 sigma is at 1. So the answer is going to be that one plus that one plus that one, which is 68 plus 13, 81.5% of the data will fall between those two numbers.
Well, that,
If you said, what percent of the data will fall between -1 and 1? The answer would be 68%. But because we're going from -2 to 1, we need each of these zones. These zones that I have, let's see, this last one has to be, let's see, that's 47 and a half. It needs to be 90 or 49.7. So this must be 2.2% over here. In other words, all of these percentages I've written in each zone have a total 99.4, assuming I got that number right. I'm 90% certain that it's 99.4.
okay. So we're trying to find it between -2 and 1.
Correct.
Right?
So I'm adding these zones that I've check marked.
Yeah. Between -1 and 1 is 68%. Between -1 and -2 is 13.5%. So I'm adding 68% plus 13.5% is 81.5.
Exactly.
That's not that hard.
No. This bell-shaped curve is one of the easier parts of statistics. In other words, statistics can get pretty hard, although in general I don't think it's that hard. Incidentally, it's also a subject that I don't tutor. If you were taking a statistics class, I'd tell every student that I don't do statistics. I do just enough statistics that I can get people through this kind of statistics. I know what mean, median, mode, standard deviation, bell-shaped curve stuff is. I know a little bit of probability, but not a lot. So if you were taking a course that was strictly statistics and probability, like I have a student that's going to do that next year, and he asked me if I'd be able to help him, and I said no. I don't do statistics. I just don't have the expertise to do it. I got a little bit of expertise. I got enough to cover this curve. So what's the next question? Does it involve the same mean and
No,
completely different?
It's completely different.
Okay, because I'll go to a new page then. But yeah, this is the curve you kind of want to be able to do. In other words, let's say they said to you, the mean is at 10, and the standard deviation is 2. That means that 68% of the data would lie between 8 and 12. And a real-life application for this might be adult men's heights.
Really?
Yeah, where the mean might be 5'9". It's probably a pretty good mean. And one standard deviation, that's what that little symbol means, might be, well, let's see, people's heights go up to about 7 feet. So that would be on the 3 standard deviation end. So I would say about 5 inches.
Really?
Now let's see what that means. That means that 68% of the adult men in the United States are going to have heights that go from 5 feet 4 inches all the way up to 6 feet 1 inch. So 68%, if this was a true statement that that was the mean, 5'9", and that's the standard deviation, then it means 68% of the people will be between those two heights.
Yeah.
And 95% of the people would be between 4'9" or 11 inches and 6'6" inches. That would be 95%. And that was probably pretty accurate. In other words, that guess is probably pretty accurate of a mean of 5'9" inches and a standard deviation of 5 inches. But see, it all depends on what you're sampling. In other words, men's height might be that, but if you were sampling how long you can hold your breath, how long the average adult can hold his breath, well, that mean might be about 40 seconds and might have a standard deviation of about 30 seconds. In other words, this whole concept can be applied to a lot of things that have a mean and a certain distribution about that mean. And that's why these curves are shaped like a bell, is because they're usually symmetrical about the mean. Of course, you can have outliers. In other words, you can have the occasional 7'6" person that he's going to be in the 0.5% of 1% of the population.
Yeah.
In other words, he'll be at least 3 standard deviations out, maybe 4.
Yeah, definitely.
Well, there's an interesting note to this. I don't know if you follow physics or not, but you remember a couple years ago when they discovered this thing called the Higgs boson?
Nope.
It's the particle they've been looking for 50 years. It was predicted mathematically 50 years ago by Peter Higgs. And
really?
They never had the equipment to actually discover it until they built the Large Hadron Collider in Switzerland and France, and then they had powerful enough equipment that they could see the particle, the Higgs particle. But what determined whether they actually had discovered the Higgs particle or not, and he'll get a Nobel Prize for this, it's that important, automatic Nobel Prize, they did it based on statistics. And they look for 5 sigma. All science does. Before something is proclaimed a discovery in science, the standard test is how many sigma, which gives you your confidence level. And they look for 5 sigma. And 5 sigma means 99.49 and then a 4. That's the confidence you have that they really discovered the Higgs boson. In other words, there's still just a real tiny bit of chance that they haven't discovered the Higgs boson. Nobody knows for sure. But their confidence level is that number, and that's enough to proclaim a discovery in science. But it's based on 5 sigma, not 3 sigma, which is 99.4%. But 5 sigma is this number. In other words, that much of the data would lie within plus or minus 5 sigma. In other words, there was a chance that the mass of this Higgs boson just happened to fall in the range that they were looking for, but not much of one. But I had this discussion with Dylan once also, having to do with certainty and probability. There's very few things in the world that are 100% certain. Everything has a certain percentage of likelihood, like this. They don't know for sure that this is the Higgs boson. They just are 99.999994% sure.
Oh, really?
Yeah. Just like when a professional baseball team were to play a minor league club, they might be 99% certain to win, but not 100%. Never 100%. Yeah. Never.
Never.
No. 100% doesn't really exist in nature. It doesn't.
True.
Even when you get down to quantum level, trying to find a particle where it's at, you never can tell. It's all based on probability. Everything is a probability answer. So what do you got after statistics here? What else are we doing tonight?
What else are we doing?
I get sidetracked on these other things. But it had to do with sigma and statistics, so.
Okay, so I have one. It says a parabola has its vertex at 4, -1, and its focus at 4, 1. Write the equation of the parabola, the directrix, and the axis of symmetry. Graph the parabola.
Okay. Let's draw its vertex first. And again, you don't have to grid these things up. You just need an approximate place. That's a pretty good vertex, right? And let's graph its focus next. What does that tell you about the parabola? Does it open up? Does it open down? Does it open sideways to the right or sideways to the left?
Up.
Has to be up.
Why would it be up again, though?
Because the focus is on the same line of symmetry as the vertex. And the line of symmetry is right there. In other words, it's called the line of symmetry because it's symmetrical on both sides of that thing.
Okay.
Okay, in other words, the parabola is merely a reflection on the left side of the line of symmetry. If I reflected it over, it would be on the right side. Now, we know how to graph it. We've got the axis of symmetry being x equals 4. That's the axis of symmetry. They want the equation. Well, we need the standard equation. First of all, you and I haven't done conic sections, I don't think. Have we at all?
No.
This is new? Is this new that you've just learned in class? Or
this is new like Thursday.
Okay, that's fine. No, that's fine. I love conic sections. I just wanted to make sure that this, I figured it was probably new, otherwise we would have covered it before.
Yeah,
so
exactly.
We kind of need to cover it from scratch, okay? So if we go back to our algebra, this is the equation of a quadratic in vertex format, right?
It is.
Well, when you talk about parabolas as conic sections, they change the format on you. they make this the format. Notice that I'm subtracting k from both sides. And there's a relationship between the focus and A. The relationship is A equals 1 over 4p, where p is the focal length. You with me?
Yes, sir.
It's complicated. So instead of using A, they make A 1 over 4p, which puts the 4p on that side of the equation. And this becomes the standard for the equation of a parabola when talking about it as a conic section, which is what you're talking about when you talk about the focus and the directrix. The directrix is going to be a horizontal line that's the same distance from my vertex as the focus is. Okay? So immediately I can answer some of these questions. That's 4, 1. If the vertex is at 4, -1, where's the directrix? What's the equation of the directrix? It's going to be y equals something.
Y equals, well,
It's got to be the same distance. In other words, this distance from there to there is the same as the distance from there to there.
y equals 2.
Well,
Or
that
direct.
is 2. P is 2. You got P right because P is the distance from the vertex to the focus. And that's also 2. But
So the directrix would be -2.
-3. It's 2 units down from the vertex.
Oh, gotcha.
Okay? So, but the fact is that, now I'm not positive that Evelyn does this. Some school systems never change and work with that and just tell people that A equals 1 over 4p. And if that's what Evelyn does, that's probably what we want to do.
Yeah, I think it is what they do.
Well, I've had students that weren't sure before, and it turns out that they use this format down here, the 4p times y minus k equals x minus h squared.
Yeah.
This actually makes it a little easier to deal with the focus and stuff, because this one, the vertex is still h and k, but additionally we have p being the focus. I know the focus here is 2. And so not sure. Is there any way you can look at your material and see which one is used as the standard? I'm betting it's the lower one. If not, then well, we only have 8 more minutes to go tonight. I'm going to assume it's the lower one, and we're going to work this problem based on that. If it turns out that this is it, then you'd still solve the same way. It's just that you got to incorporate A being 1 over 4p. So let's do it the way I believe is most likely. As long as you can figure out how I get from this standard format of vertex format to this standard format for a parabola and a conic section vertex format. Now, yeah, they're a little different, but notice the only difference is A is equal to 1 over 4p. If I substitute A as 1 over 4p, multiply both sides by 4p, I get this on the bottom. So the only difference between these two formats is A equals 1 over 4p. Okay? Now, let's figure if we can figure out what the equation is. Well, if I work with the bottom equation, I know that P is 2. I can tell what the difference between the vertex and the focus is. They gave me that. So that tells me what P is immediately. And then K is the y-coordinate of the vertex, which is -1, which turns that into y plus 1. And H is the x-coordinate of the vertex. So that's your equation right there. And notice that, boy, when you know all of those things, in other words, when you know the focal length and the vertex, this format actually works quite a bit quicker and easier.
Yeah.
And it gives you this. And that's actually the equation of it. That would be a suitable answer. You don't need to put it back into the original vertex format. In other words, I don't need to divide both sides by 8 and subtract 1 or subtract 8. No, excuse me. If I were to solve this for y, I would divide both sides by 8 and then subtract 1. And that would put it back into that format. But if we're talking conic sections, then that's an okay answer there. That's the equation of a parabola in standard vertex format. And in fact, if they would have given you this as your only piece of information, and they would have said, graph it, or tell me where the vertex is, or what's the focal length? Well, I know that 4p is the coefficient of this. So I would say 4p has to be equal to 8, and the focal length is 2. And you know the focus is always inside the parabola. It's in the direction that the parabola opens.
Yep.
So now why is the focal length important, or why is the focus important? There's a very interesting property about parabolas, reflective. Any thing coming in bounces always to the focus, no matter where it hits. If I hit there on the side of the parabola, it reflects to the focus. So when you build a telescope to study the light coming from the stars, you build it in the shape of a parabola, because all the light gets focused right in the center. In fact, if you go outside and you look on top of roofs at anybody who has a direct TV dish on their roof, it's in the shape of a parabola, and the thing you see sitting in the middle, sticking out front, is where the focus is of that parabola.
Yeah.
That's the receiver. In other words, it's pointed at the satellite, and all of the energy coming from the satellite hits that parabolic dish and gets focused to the focus, which is where your receiver is. So that principle of parabolas, the reflection principle, same way if you build a flashlight. You design that shield in the shape of a parabola, because it takes the light from your light bulb and it reflects it all in the same direction. So instead of the light just dispersing in all 360-degree directions, it's focused on the path you want it to be focused on.
Really?
Yeah. So this reflective property of parabolas, which they never tell you about when they're just talking quadratics, the reflective property only comes up when you start dealing with parabolas as conic sections. Even though they're no different, a parabola is a parabola. It's a quadratic. It's just that there is this interesting property that parabolas have, ellipses have, and hyperbolas have. They all have a very, very interesting reflective property. There are some telescopes that combine a parabola, an ellipse, and a hyperbola to reflect light in 3 different directions before it hits your eyeball. So that's the main reason you study conic sections, is because of the reflective properties that they all have. And that's why foci are important. And have you studied ellipses yet?
No, we have not.
Well, ellipses have two foci. There's one there, there's one there. And if you're in an elliptical skating rink and you fire a hockey puck, it always bounces to the other foci, no matter where it hits. I can fire that hockey puck there and it bounces there. I can fire it here and it bounces there. So ellipses have that super interesting reflective property. And that's why they're interesting. And hyperbolas have the same thing. But Justin, I'm going to have to go. Dylan awaits.
Thank you very much.
We have back-to-back online sessions. It's hard to get out of one and into the other without being late. So
yeah.
Yeah.
Well, these are starting to make a little bit more sense.
Well, good. Good.
Yeah.
Talk to you at your next session, Justin.
Awesome. Thank you.
Bye-bye.
Bye.